Hello everyone, welcome to a new video. Harsh Verma this side, and today we are back again for another topic, Border Gateway Protocol, an outline from the book Network Warrior. For those who don't following this series, actually we are going through the book called Network Warrior, which specifically tells about the things that we missed during our CCNA preparation. So those who are new, let me show you the book. The book is this, The Network Warrior, Everything That You Need to Know that was not on CCN exam by Gary Donho. If you want to purchase this book or have a copy of your own, I will certainly put a link into the video description so you guys can see. And that link will be non-affiliate, so you feel free to use it. Okay, so without any further delay, let's go to our very short and quick introduction about BGP. BGP stands for Border Gateway Protocol. It is also called the protocol of the internet because it is the only external gateway protocol. External gateway protocols are those which are used to connect different autonomous system together. And by this autonomous system, we are talking about the IANA certified autonomous system, a number that is assigned to a certain organization uh, to its router. So it can differentiate between itself in the whole internet. Okay, so the book has only 3 to 4 points that I've noted, but as an introduction to BGP, it is my responsibility to different BGP metrics. So the metrics are kind of we have already studied what a matrix is and what it does role it play in a protocol. For example, it defines what things it take care of in path in order to calculate it cost, in order to decide which path to take and which path to actually introduce to the routing information base RIB table. Okay, then RIB table will itself decide on the basis of the administrative distance. So as per the protocol, uh, it is not our responsibility what RIB will insert into it. Actually, being a network engineer, it is certainly ours, but from the context of protocol, it's not. So, without any further delay, let's start the BGP metrics. And the BGP metrics are here, it is mentioned 4, 5, 6, 7, 8, 9. So, the most common 9 metrics are mentioned here. The first is local preference. A higher value is preferred and it is used inside one autonomous system. So despite being an external protocol, BGP also handles the internal routing somehow. Actually, BGP itself is divided into IBGP and eBGP. IBGP stands for Internal Border Gateway Protocol, while the eBGP stands for External Border Gateway Protocol. If you have took care in my previous video, I have already told you that only in the case of BGP, the internal BGP has an administrative distance of 200, while the external has an administrative distance of only 20. So, in case of BGP, the external path is more preferred than the internal path. Okay, so having a higher local preference, that path will be much more uh, encouraged, basically. Next is autonomous path, the route length or sequence. The shorter it is preferred. So regarding the autonomous path, I also want to add one thing which is written in the book that network in BGP is referred as a prefix. We know a prefix is the slash and the value which is well under within 32 in case of IPv4 addresses. But in BGP, prefix is the autonomous system itself and it used to be accumulating. For example, the keyword it says that the route length and sequence shorter is preferred. So how does this prefix works? Let me go through this statement. So suppose we have our own autonomous system as the beginning of path. For example, we were advertising a route which is 192.0.2.0/24. Okay, so we have an autonomous system of 100. So when we advertise this part, we will append its autonomous system along with its route. So it will become 100, then 192.0.2.0/24. After our path go to another autonomous system, then what that router will do, it will append its 200 autonomous system number to that path. Now it will become the 200 100 192.0.2.0/24. And if that happens to three or four times, for example up to the fourth, it may not be in consecutive order that it appends 200 after 100. It may be that our third router or fourth router has an autonomous system of 5436, so it will append that value 5436, then 200, then 100, then the IP or network address. Okay, so this is how prefix is built, and the shorter the prefix is, matlab the less the values are appended to it, the more it will be preferred because it will be a shorter path. And this also helps in case, suppose if a long prefix path also turns around and comes to again to that same router, it will certainly check its own prefix whether, if an autonomous system suppose 200, it will check if 200 is already in the path somewhere. And if it's find that it's a 200 which is itself its own autonomous system is already inside the path, then a router will decide and agree that this route is a loop and it has come back from what I advertised earlier, so it will does not accept that path. Okay, as I said, this is the route selection criteria. Suppose path 1 has of the same network, it is 300, 200, then 100, then this network address, and the path 2 has 500, then 100 as a. So we have to consider the length. The shorter the length is, more preferred. So autonomous system 400 path will be more preferred because it's shorter, because it only contains the two prefixes. Okay. And the third one is multi-exit discriminator, which is mainly used between neighboring autonomous system to prefer lower cost entry point. So MED is some values that we can set on the router itself, that at what MED it should advertise the path. Next is weight, which is a Cisco specific metric. So because routing protocol BGP is so big, so certain vendors configured or established their own metric. So weight is a Cisco specific metric, and the higher the weight, the more that path is preferred. Next is origin type, the IGP over BGP over incomplete ranking. So if a path is originated internally over EGP over incomplete, I'm not certain how this works, because I have heard that the external path is way more preferred over IGP. Okay, next is next hop reachability. IGP cost to next hop. I can influence selection if IGP metric when relevant. Next is EBGP versus IBGP preference. Typically preferred route learned via EBGP over IBGP. I have already mentioned it. Next is router ID or tiebreaker. When attributed are otherwise equal, lowest router ID and other deterministic tiebreaker. So basically, just like OSPF, we can also set the router ID of the router in the BGP as well. And here, the lowest router ID will be preferred. Next is community and policy outcomes. While these are not path metrics themselves, they are often used to set and modify attributes that affects the decision, which is local preferential, MED, multi-exit discriminator, and filtering. So policy outcomes, the using of route maps or using of ACLs or any kind of path modulation technique can also affect the decision making in BGP. Okay. Now, going back to our terminal, when advertising a prefix, an autonomous system number is prefixed onto the autonomous system path. I just told you how this works, appending of, not appending, prefixing of the autonomous system over the network. Next is when an autonomous system learns about this prefix, it also learns about this path, and it got its path length, and it also checks that whether its own autonomous system has already baked into that or path. And if it found that it is understood to be a loop, and it cancels or restricts that route further. In case of re-advertisement of learn prefix, it also appends its own autonomous system to it. And that's it for this video. I know it's a very short introduction, and I myself feels like I have not explained the BGP in detail, but BGP is certainly a topic of practical exploration. So I will be doing some BGP labs in my office today. And if I will ask suddenly from my seniors how BGP exactly works, and once I got the detail, I will certainly share with you. Thank you for watching. Thank you for joining.